And this is problem number 3 from section 3.7. In this problem, they want you to use implicit differentiation to find dy over dx. And they give you x plus cotangent xy equals 6. So let's start by taking the derivative of x. We know the derivative of x is 1. And then we'll take the derivative of cotangent, but we're going to have to use the chain rule here because we have a function on the outside and a function on the inside. So let's take the derivative of the outside function first. So we're going to end up derivative of cotangent being negative cosecant squared. So this is minus cosecant squared xy. And then we're going to take it times the derivative of the inside. So I need to do the product rule for the derivative of the inside. So I'm going to say u equals x, u prime, v, v prime. So u is x, so u prime is 1, v is y, so u prime is going to be 1 dy over dx. So when I multiply this, I end up with 1 times y, which is y, and then plus x times dy over dx, so that'll be x dy over dx. All right, we don't worry about the 1 written right there. And this is all going to equal 0. So I have 1 minus cosecant squared xy times 1 plus x dy over dx. What I need to do is I need to get all this by itself on one side and dy over dx staying on the left side. So let's go ahead and move the 1 over. So we'll subtract it over. We get negative cosecant squared xy times y plus x dy over dx equals negative 1. I'm going to go ahead and divide by negative cosecant squared xy on each side. And we divide the two negatives, they become positive, right? So we end up with y plus x dy over dx equals 1 over cosecant squared xy. And now I'm going to subtract the y over, so I end up with x dy over dx equals 1 over cosecant squared xy minus y. Let's subtract the y from each side. Finally, I need to divide by x, so I get dy over dx equals, when I do dy over dx, I end up with 1, I'm dividing by x, right, from each piece. So 1 over x cosecant squared xy minus y over x. Now I can combine these two things together. Technically I'm done, but I could simplify this a little bit more. So let's go ahead and do that. That's dy over dx. I'm going to multiply this piece by cosecant squared xy. So when I do that, I can combine this together and say that this is 1 over x cosecant squared xy minus cosecant, well, this would be y cosecant squared xy over x cosecant squared xy. So then I have dy over dx is equal to, I can say that this is now all just 1 minus y cosecant squared xy over, and then on the bottom we'll have x cosecant squared xy And if I wanted to, because this is cosecant squared, and cosecant is essentially like the inverse of sine, if I wanted to, I could multiply the top equation by sine squared xy, and the bottom equation by sine squared xy. And this doesn't really change anything, right, because I'm multiplying by the same thing on top and bottom. But this would be dy over dx equals, when I multiply that, I end up with sine squared xy when I distribute it to the 1. I multiply sine squared xy times cosecant squared xy. These two things cancel because, remember, this is 1 over sine squared xy. So they cancel. I'm just left with minus y over, on the bottom I multiply this times cosecant, and it cancels, so I'm left with over x. And so this is the derivative of y with respect to x in a more simplified version.